Hello, hello. So in this small session, I'm going to continue my quest for the next goal, which is implementing a finite state machine and somehow make it work with the ECS library. It seems like this is a pretty complex task, although to me from the outside it doesn't look like that, having built both ECS and finite state machine libraries. But it seems like making them work together, it's not really that simple, since it seems cumbersome to put the states on a as components. And on the other hand, to me it looks like a solution where state should be somehow injected in the entity. But I found this article, so I'm following a thread on Unity forums, which is titled "How to Implement FCM in an ECS Architecture." And I'm going to follow all the discussions. This is from 2018, but I'm gonna follow all the discussions. So next was this article, which by the way has 70 comments. Designing Bomberman with an entity component system. Which components? So let's see. Today I found a new article on implementing a Bomberman clone using an entity system in C#. But I feel it doesn't quite work. It's a well-written article with some great illustrations, but the author's components struck me as overcomplicated and too behavior-focused. If you're designing a game based on an ES, this isn't a great way to do it. It feels too much towards all-style OP game objects. This is something we want to avoid, since in the old engine I already did this and it's not scaling in any shape or form. So if we go here, for example, in the old engine, you see we have the class player extends actor, and actor extends entity, and entity implements a subject, which is actually extends subject, which is actually a pull object, and so on. And you can see how this is being transformed into a shit show, because extending on multiple levels means that you inherit a lot of methods which are not actually useful. So it becomes cumbersome. Okay, let's follow. This is an opportunity to talk about good and bad directions in component design. I really like the author's idea of using Bomberman as a reference. It's simple, it's a well-known game, but it's got a lot of depth. This is a very good observation, and I'm gonna show you why in a second. So where was this? Assets, ideas. So that's exactly how I started with the old engine, a Bomberman, right? But then while doing this, I realized that there's so much depth in this gameplay. For example, the original Bomberman game has these squares which on which the player moves, but it doesn't move in a but the player moves in and the entities move in a linear way, like in a smooth way. They don't just appear in the next box. And also even if the map is somehow it's split on this in these grid that looks like a big grid, like for example 64 by 64, the collision detection and the movement is actually on a smaller grid. Okay, read the original article to refresh your memory on Bomberman and how it works, then come back here and we'll do a worked example of choosing components for the game. I'll completely ignore the programming issues and only look at the design issues. Let's see, case study, Bomberman mechanics in an entity component system. The Bomberman series of games are simple games with an interesting set of mechanics. Having used ECS framework in a few projects, I thought it would be useful to see how we can implement these mechanics using this pattern. I won't go into detailed introduction of ECS here. For a great primer on the topic, have a look at Understanding Component Entity Systems. I also provide a working game that contains the bulk of PvP core mechanics and look at what value ECS provides us and where there is room for improvement. The game leverages ECS in lots of other ways, but for the purpose of this article I will only discuss the core game mechanics. For the purpose of clarity and language independence, code samples in this article will be a sort of pseudocode. For a full C# implementation, see the sample itself. Also, I use bold capitalized names to refer to components. So a bomb refers to the official component, while if I mention a bomb, I'm just talking about the concept or the entity that represents the concept. To me, this is clear. Having used ECS, it's absolutely clear. This statement can be very confusing if you never used ECS. So he's actually talking about bomb as a component when you're throwing a bomb, and then you have the entity, because once you're throwing it, it becomes an entity on the screen and part of the game loop. Let's get to work. Before designing any system, it's necessary to understand the scope of the problem we're trying to solve. This means listing out all the interactions between various game objects. From there, we can figure out the right abstractions to use. Of course, knowing all the interactions is possible if your game is under development. Or even if you're trying to make a clone, because there will be things you missed at first. One of the advantages of ECS is that it lends itself to making changes as needed while affecting a minimum of other code. A rough summary of PvP Bomberman gameplay is as follows. Players plant bombs that destroy other players and disintegrate blocks. Disintegrated blocks leave behind various power-ups that augment the destructive power of your bombs or affect player speed. Players complete Players compete to see who is the last to survive as the clock counts down the total destruction. Without further ado, let's look into the classic bomb mechanics Bomberman and come up with a design we can implement with ECS pattern. With one hard block, this is a hard block, 2 soft block, 3 empty space. When a bomb explodes, the explosion shoots out in various directions. The following things can happen. Hard blocks block the path of explosion. Soft blocks block the path of explosion usually and are destroyed. They randomly reveal a power-up. Untriggered bombs will detonate. Any players hit by the explosion will die. One bomb explosion can trigger another bomb. It seems there are two concepts here: how particular objects react to explosion, dies, triggers, disintegrates, and how a particular object affects the path of the explosion, blocks it, or doesn't. We can create an explosion impact component to describe this. There are only a few ways an object can affect the path of the explosion, but many ways it can then react. It doesn't make sense to describe the myriad ways of an object can react to an explosion in a component. So we'll leave that up to a custom message handler for each object. So explosion impact might look like this. Explosion barrier, non-soft hard class explosion impact. I'm guessing this is like extends here. Explosion barrier. So explosion impact has an explosion barrier. What? Now let's look at the init properties of an explosion. This basically depends on the type of the bomb, but it's useful to distinguish bombs versus explosions. Since bombs have additional properties like countdown, timer, and an owner, explosion can propagate any or all of up to 8 directions, sometimes propagate through soft blocks, pass through bombs which have blue explosions, different propagation ranges or an infinite range, sometimes propagate through hard blocks. Power bomb or full fire gives bombs infinite range. There are two obvious ways to model an explosion. You could have a single entity for an explosion or an entity for each piece of explosion as it propagates out. Bomberman is a grid based, so the latter is feasible. Given that an explosion can propagate unevenly depending on what it hits, as previously discussed, it would be somehow tricky to represent with the same entity. Yeah, it would be, but in the same time, shouldn't this be like a snake kind of scenario? I mean, you have multiple entities tied to one entity. It seems then that one entity per explosion square would be reasonable. Note, this may make it seem tricky to render a cohesive image of an explosion to the screen, but you'd actually have a similar problem if your explosion was a single entity. Actually, this is not that hard if you know the array. You have the array of explosion. I mean, the ends have one sprite and the middle has a different sprite, so no problem. A single entity would still need a complicated way to describe the shape of the overall explosion. Yes and no. Dangerous bombs explode in a square instead of a line. So let's take a stab at an explosion component. I don't know why he had to go this route. I mean, he should kept the examples very simple. Classical Bomberman explosions. Class explosion, extends component, boolean is pass through. Does it pass through soft blocks? Is hard pass through. Does it pass through hard blocks? Range. How much further will it propagate? Propagation direction, direction. Float countdown, how will it, does it last? Float propagation countdown, how long does it take to propagate to the next square? Propagate direction. Sorry about that. Of course, since we're using ECS, things like position, explosion, image are handled by other components. I've added 2 more fields to the explosion component that bears some mention in countdown, which represent how long an explosion lasts. It's not an instant in time, it lasts a short duration. Aha, so countdown is like a ticking rate during which a player can die if they walk into it. I also added propagation countdown. If Bomberman, from what I can tell, explosion propagate instantaneously. For no particular reason, I decided differently. So how does this all tie together? In an ECS system, in an ECS, systems provide the logic to manipulate the components. So we'll have an explosion system that operates over explosion component. Yes, you can look at the sample project for the entire code, but let's briefly outline some of the logic it contains. First of all, it's responsible for propagating explosions. So for each explosion component, update countdown, propagation countdown. If countdown reaches 0, delete the entity. Get any entity underneath the explosion and send them a message telling that they are in an explosion. Yes. If propagation countdown reaches 0, create new child explosion entities in the desired direction. Okay. Explosion system also contains the propagation logic. It needs to look for any entity underneath it with an explosion impact component. Then it compares the explosion impacts explosion barrier with properties of the current explosion, its hard pass through, and decides if it can propagate in what directions. Yeah. Power-ups. Next, we'll trace the path from collecting the power-ups to the player dropping bombs. I used a subset of 12 of the typical Bomberman power-ups. I've left out the ones that let you kick, punch, and pick up bombs. I didn't have time to implement them in this article, but it could be a good follow-up. As before, let's look at our scenarios, what the power-ups can do, and come up with a design. Bomb up. Okay, fire up, speed up, full fire, dangerous, pass through, remote, landmine. Perfect. Various power-ups that have been revealed under disintegrated soft blocks. Okay. So they can affect other things like player speed. So power-ups are different concept than bombs. Furthermore, power-ups are not exclusive, they combine. So if you have a couple fire-ups with a dangerous bomb, you can get a bomb that explodes in a bigger square. Pass through bombs, propagate through soft blocks. So essentially the player has a set of attributes that indicate what kinds of bombs they can place. Yeah, so this can be like a bit mask. The power-ups modify those attributes. Let's take a stab of what the player info component would look like. Keep in mind this won't contain information like position, current speed, or texture. This information exists in other components attached to the player entity. The player info component, on the other hand, contains information that is specific to the player entities in the game. Player info extends component int player number, some way to identify the player. This could also be the player name, string float max speed, permitted simultaneous bombs, first bomb infinite, first bomb landmine, can remote trigger. So he put a property for every power up. When a player drops a bomb, we look at its player info component to see what kind of bomb he should drop. The logic is to do so is a bit complicated. There are a lot of conditional. For instance, landmine bombs look different than dangerous bombs that explode in all directions. So when you have a landmine that's also a dangerous bomb, what texture is used? Also, power bombs, power-ups give us infinite bomb range. But we don't want an infinite range when the bomb propagates in all directions, or else everything on the board will be destroyed. So there can be some fairly complex logic here. The complexity arises from the nature of the Bomberman rules though, and not from any problem with the code. It exists as one isolated piece of code. Okay, we also need to consider how many bombs the player currently has active, undetonated. We need to cap out, correct, and also apply some unique attributes to the first bomb they place. Why? Instead of storing the player's current undetonated bomb count, we can just calculate how many there are by enumerating through all bomb components in the world. This avoids needing to cache an undetonated bombs. Well, I would have cached it, but whatever. This can reduce the risk of bugs caused by this getting out of sync. Well, I don't know. I would have cached it, but let's see. This can reduce. Okay. Let's take a look at the final piece of the puzzle. Bomb. Float fuse countdown. Owner. Range. Pass through. Hard pass through. Okay, so you count by the owner. Then we have a bomb system that is responsible for updating the fuse countdown. When a bomb's countdown reaches 0, it deletes the owning entity and creates a new explosion entity. Yes. In my CS implementation system can also handle messages. The bomb system handles two messages, one sent by explosion system to entities underneath an explosion, which will trigger the bomb. So we can have a chain reaction. And one sent by the player input handler, which is used for remotely triggering the bomb. Explosion bomb player components share a lot in common. Range, propagation direction. Is pass through, is hard pass through. Does this suggest that they should actually be in the same component? No. The logic that operates over these three types of components is very different. Yes, and it makes sense to separate them. We could create a bomb state. Let's see, a bomb state component that contains the similar data, so an explosion entity would contain both explosion component and bomb state. However, this just adds extra infrastructure for no reason. There is no system that would operate only over bomb state components. The solution I've chosen is just to have a bomb state struct, not a full-on component, and explosion bomb player info have this inside them. For instance, bomb looks like struct bomb state is passed to class bomb component, and then it has a bomb state. Okay. When a bomb is created, it inherits the abilities of its player at the time it is placed. Yeah, but what he's doing here is just moving some properties in a different object. But he doesn't have any logic here. So it's just like a minor tweak. When a bomb is created, it inherits the abilities of its player at the time it is placed, range, etc. Instead of referencing the player abilities. Okay, I agree with this. I believe the actual, because you know what could happen is that the player might die and then you lose the references, but then the bomb can still explode and it can end up the game in a tie. I believe the actual Bomberman logic might be different. If you acquire a fire up power up, it affects already placed bombs. At any rate, it was an explicit decision I made that I felt was important one. So soft block is no protection against the pass-through bomb. Let's finally talk about power-ups themselves. What do they do? What do they look like? I have a very simple power-up component, class power-up component with type sound. Power-up type is just an enum of different kinds of power-ups. Power-up which operate over power-up components and control picking them up. Just has a large switch statement that manipulates player info. Okay, I get it. So power-up system with a switch over the enum, and then just put the logic in the middle of the case statement. Oh, or horror. I did consider having different messages handler attached to each power-up prefab, which contain the custom logic for that particular power-up. And that is the most extensible and flexible system. We wouldn't even need a power-up component or power-up system. We'd simply define a player is colliding with me message. I actually went through this problem myself. Message which would be fired and picked up by a custom power-up specific message handler. This really seems like over architecting to me though, so I went with a simpler, quicker to implement choice. Here's a little snippet of the switch statement where we assign the player capabilities based on the power-up. So power-up type bomb down, permitted simultaneous bombs, okay, dangerous bomb, propagation direction all. Okay, so it just manipulates the player bomb state. Okay. Prefabs. MyECS allows you to construct entities, templates, or prefabs. These assign a name to a template, example this, and associate. Holy shit, I didn't thought about adding prefabs to my engine. So basically, if you want to create a player that can throw a bomb, you just have a prefab. Yeah. I was always asking myself what a prefab is, but it's such a simple concept. You can tell our entity manager to instantiate the bomb up power up, and it will create an entity with all the right components. I won't go into details on the values used in each. I'll simply list which components each type of entity uses, with some comments where useful. You can look at the source code. There are just examples of prefab. So player, placement, aspect, physics, input map, controls, what inputs, input handlers. An ECS also gives you the flexibility of creating new types of entities. It makes it easy for you to say, hey, what if I combine this with that? True. This can be a good for brainstorming new kind of mechanics. True. What if you could take control of a bomb? Add input map to a bomb entity. What if an explosion can cause other player to slow down? Add power up to an explosion entity. What if explosions were solid? Add physics to an explosion entity. The game is grid-based, but the player can move. Exactly. The game is grid-based, but the player can move on such more granular level. This is one of the first things that I learned when programming a grid, is that even if the game is grid-based, the player can move more granularly. So the actual grid on which the player moves is smaller than the ones with the one that dictates the collision detection. So myself here, even if I have entities that were 64 by 64 like this one, the grid system was actually 16 by 16. So the player moves by, I think, 8 pixels, 8 by 8 pixels, something like that. Okay, let's go further to see. So far we haven't learned too much. I mean, the dude is using state in a very... He doesn't have transitional states. That's the problem. And he doesn't have... It seems like he doesn't have too much conditions from going to one state to another. Okay, let's see. So that was the easy way to get the behavior, that behavior without having to do much work. However, a lot of the gameplay is grid based. Bomb can only be dropped in integer location, for instance. So I also have my own very simple grid collisions detection, which lets you query what entities are in this grid square. Oh my god, I remember what this was a big problem for me. Sometimes these two methods came into conflict. The problem isn't anything ECS specific. Yes, of course, it's not ECS specific. In fact, ECS encouraged my usage of Farseer physics to be entirely limited to my collision system, yes, which operates over physics components. So it would be very easy to swap out the physics library for another. Correct. This is the case for us as well. The physics component itself has no dependency on Farseer. Yes, the physics component doesn't have a dependency on this, but the system, I think, will have a dependency. Another problem that I faced is that there is a tendency to make certain problems fit into ECS way of thinking. One example is the game state. Okay, finally we get to the meat of it. One example is the state needed for the overall game, the time remaining, the size of the board, and other global state. I ended up creating a game state component and an accompanying game state system. Game state system is responsible for displaying the time remaining and determining who won the game. It seems a bit awkward to cram it into the ECS framework. It only ever makes sense for there to be one game state object. It does have some benefits though, as it makes it easier to implement a save game mechanic. My components are required to support serialization. My components do, because I want a save game capability. So I can serialize all entities to a stream and then deserialize them and end up exactly back where I was. This is exactly my aim with the engine. One decision that I often faced was, do I make a new component type for this or just attach a script for custom behavior? This is exactly where we are right now, because I don't know if the finite state machine should be attached like a custom script or is it like a new component. Sometimes it is a fairly arbitrary decision as to whether a piece of logic merits its own component and system or not. A component and system can feel a bit heavyweight, so it is definitely essential to have the ability to attach custom behavior to entities. This can make it harder to grok the whole system through. I currently have 3 ways of attaching custom behavior to an entity: input handlers, okay, message handlers, and scripts. Okay, so input. In my case, the input handler is on a component in a different system. But I understand what he's saying here. Let's see. Scripts are executed every update cycle. Input and message handlers are invoked in response to input actions and sending messages. I was trying out a new input handler methodology for this project. It worked well, but it might make sense to combine it with message handling. I was using the keyboard to control the player. When it came time to implement the gamepad support, it took all of 5 minutes. I was inspired by this article: entity fire up or placement aspect explosion script container. So you have an entity and you have these components: placement, aspect, explosion, impact, and then you have a script container. Oh, this is like in Roblox. This is like in Roblox when you attach a script to, was it to an entity or to a component? You can attach scripts to component. So you attach a script But I don't like it because a script is like something custom. It's like modding. A script is like modding. And I just have a generic finite state machine to implement. That's it. A power-up entity generic container is defined by its components: placement, aspect, explosion impact, script container, power-up. Script container allows attaching scripts for custom behavior. In this case, a wiggle script is responsible for wiggling the power-up around. Scripts often need to store state. For instance, a script that makes a power-up wiggle or a bomb entity wobble by changing the size property in its aspect component needs to know the minimum maximum sizes, correct? And what point we are in the wobble progression, correct? This is my problem right now. I could make scripts full-fledged classes with states. Yes. This is how I actually did it. So in the old engine, what he's saying here, I could make scripts full-fledged classes with state. This is exactly what we did last time. For example, player eat state, full-fledged class with state, because you have the status of update and render. And then you have a select food, and you eat the food, and then the food, you send a message, player ate the food, and you destroy the food, and so on. However, this causes problems with serialization. Each script would need to know how to serialize itself. Okay, and how do you do that? So in my current implementation, scripts are simply callback functions. The state they need is stored in a generic property bag in the scripts component. The scripts component simply stores a list of IDs that are mapped to a specific callback function. This makes the C# code, script code, a little cumbersome, as each get and set of a variable is a method call on the property bag. Conclusion. Theory is nice, but I hope this article helped by showing a practical implementation of some mechanics with ECS. The sample project attached implementing X and A 40. Okay, so what do we learn? We learned this, that we could have a script container attached. And this means that I now understand how I can make the game to be modded from the external. Let's see the comments as well, because comments usually hide a lot of stuff. Okay, informative article, very easy to digest. Thanks for sharing. A note: I know you provided the source code, but it would be nice if you could put up a small example of methods and logic of a system as well, just briefly, as you have with components. Interesting and informative. It seems to have little to do with real Bomberman though. Bomberman is a product of 8-bit, 16-bit era and ran on systems that have very little RAM and weren't programmed in higher level languages. As such, there were no power-up components. Power-ups were just simple tiles placed in the map. Making them components or having them as active game objects would have taken too much RAM and too much processing. As tiles, they are effectively static. Yeah, so what he's saying is that you have an array grid, an array matrix which is composed of 0, 1, 1, 1 on the sides where you have the hard blocks. So something like Sublime, let's see, something like this, where you have 1, 1, 1, 1, 1, 1, 1, 1, and then, wait, what? But the part in the middle here is like 0, 0, 0, 0. So you have this area where the players can move. Hi, Mike. What up? And what he's saying is that in the old days, oh god, I pressed insert. He's saying that in the old days you didn't have enough memory, so then instead of a wall, making an entity a component. Actually need another row here for this to make sense. So 1 are hard blocks, and if you have a power up, you just put 2 here or 3, depending on the type of power up. And the player would be somewhere in the higher up range, maybe 99 or 98. Dude, this is passion. I'm not really that busy. I'm making a So this time I'm converting my old engine, which is all P based, to an ECS1, and I'm also open sourcing it. And finally, at the end of this, I hope I can release my game. The problem with the old engine is that I created so many gameplay types and so many variants of the same game that I ended up not knowing what to do next, and also reached the limits of the former engine. And now it's more motivating to make the engine open source, put it out there, and then just focus on the game and gameplay, polish the gameplay, publish on Steam, and that's it. Because I left it, so last time I coded on the game was 2018, I think. That's my last video on 3 years ago. The hell was I doing here? I don't know, I was doing something. What was I doing here actually? Grid and tiles. Wait, what? Pathfinding. I don't even remember this. I don't even remember what I did here. I had 3 years, 4 years actually, where I was kind of lost in myself, so didn't actually cared about this anymore. I lost the drive to do something, And now I'm just remembering everything, so everything comes back to me. This looks like this is very cool. What type of gameplay was I aiming to? I think I was just playing with the grid system, which enables the AI pathfinding. Yeah. Okay, so let's see the commentaries, all the comments on this, and then I'll move to implementing the state machine. The player tries to take a step in the direction of a power-up. The code looks for a tile. It's a power-up tile, exactly what I was saying here. It's a power-up tile. Replaces the tile with the ground tile, in our case 0, and sets a flag in the player that they now have the power-up. As another example, bombs don't expand, they blow up at their defined size instantly. Google SNS Bomberman video. I remember on PC being different, so but this is a new, wait, this is a new gameplay. The article is a great introduction into ECS, but it's also arguably an introduction. Will you finish in 2024 the engine and game? I think the engine, I can finish it and launch it, which will also help me in my career. I mean, if I want to go back to working in enterprise with the full TypeScript and Node.js, but the game, there's no way I can finish the game without taking a leave, an absence, or a vacation. And I'm thinking of doing that in the following years. I don't know when, maybe next year, because I need space to be creative with a simple gameplay and a simple story, which I already have, but you know, devil is in the details. I think the engine will be ready in 2024. I'm already publishing parts of it, so. By the way, what are you up to? What are you doing? Like, I haven't been on Dino's Discord in a while. I don't think he hangs around there, by the way, but I see that on Twitch I have regular notifications that he's streaming, and I think he's doing an engine in C++, if I'm not mistaken. Let me check. Yeah, so he's not active in core community, right? Man, I said I will talk with him, and I just delayed that because I was, I was kind of lost with my thoughts. So right now my plan is to finish the engine, have some sort of demo, and then start a discussion with him. Don't go on Twitch. I think he also streams on YouTube, maybe. I don't know. Let me see. Dino. No, he has the music stuff on. Ah, custom shader. He has some stuff here. I see live coding session. Yeah, I want to talk with him after I do this. Get some inspiration, maybe record it for the YouTube. I feel like he has a lot to say to, you know, to us aspiring game developers. The article is a great introduction into ECS, but it's also arguably an introduction into over-engineering. I felt that too. Sorry, that sounds like a judgment, and arguably anyway your game works is fine. It's just the limits of all systems force and suggested different solutions. Okay. These solutions have their own advantages and disadvantages. For example, using the tile-based, not non-game object solution, you can easily make a level that is filled with bombs because the bombs themselves are tiles. They can only be placed on tile boundaries. When you place one, on the ground tile is replaced with bomb tile. That means you are having 1 to 1000 bombs. Takes the same amount of processing. Yes, I actually know this from my grid implementation, which I will also do on the channel. They only become game objects when they are moving, and usually only a few are moving at any one time. Possibly max 2 per player. In other words, the bomb is a tile. If the player kicks a bomb tile and has the kick power up, the tile is replaced with a ground tile and a game object is spawned. The bomb moves down the hole until it hits the end or player stops it. The closest ground tile is changed back to the bomb tile and the game object is destroyed. The bombs can appear to tick using tile animation rather than a game object per bomb. All you need is an array of bomb tile locations and a time they were placed. But this is state. When you're talking about tile locations and time, actually when you're talking about time, you're talking about state. A single function walks the array. Any bomb whose time is up explodes the tile. That is like a system. He's describing a system here. So much less overhead. In fact, because bombs are added to the array queue as they are placed, the code only has to check the oldest bomb. This is a mistake. This is naive, because you can have a player touching. Let me see here. If a player touches a bomb, then it's from outside to the bomb, but the bomb itself shouldn't. I see. Might be right on this. So in general, only one bomb needs to be checked each frame to see if it's time to explode. Actually, this part is correct. Or 2 or 3 for those rare occasions where 2 or more players put bombs down on exactly the same frame. Even explosions are tiles. The moment the bomb explodes, the code goes and replaces the ground tiles. Okay, that means the tile on the entire board can be explosion tiles again. There is no processing. Problem is that when you explode something, you also have to keep the underlying objects rendered behind, and that was a problem that I had with my engine that you need to render 2 or more objects on the same tile, because you have an explosion on top of a box or of a rock, and the rock doesn't get destroyed. So when the explosion diminishes, the sprite diminishes, you still have to render the rock behind it. But indeed, with the old systems, you didn't have this. Each player just checked the max 2 tiles they are straddling. If there are explosion tiles, then the player dies. Yeah, because the movement was up and down, and only you couldn't move in diagonal. So you had maximum of 2 tiles of check. And that was something smart for a game. Memory-wise, in-game objects term, the original Bomberman likely only had 1 game object per player, 1 game object per moving bomb. Anything else was tile, with a few arrays to remember which tile to change later, like changing explosion back into the ground tiles when the explosion is done. You see exactly what I said. Having bombs as tiles also has other advantages. Collisions are simple. The player checks if the tile he's on is an explosion tile. If so, he dies. Then he checks in the direction he's moving. If that's explosion, he dies. If it's a power-up, he changes into ground tile. If it's ground, he moves. If it's anything else, then he can't go that way. So bombs become barriers without any extra code. Yes. All these solutions make this type of game possible in 1 megahertz. Okay, but they also have benefits. Collisions are easy, explosion bombs. Yes. Okay. So I read this article, which is called Case Study Bomberman. Put this in chat. Now we're on to the original article, Designing Bomberman. And let's see what this author thinks about this. Now reading. Let's see. Choosing your components. Design rule for components. Components are data, not code. Game state, not functionality. Components are as small as possible. Atoms, the smallest set of data possible for a particular aspect of entity. Components never share data. In database terms, everything is normalized. If data should be in 2 components, but you can't decide which, create a 3rd component for it. Okay. Looking at Bomberman, list of behaviors, list the behaviors, list the data. This is an iterative process. I start with 2 lists written at the same time. Writing items in 1 list often makes you think of something that's needed in the other list, so you keep jumping back and forth. No. ECS entity components. So there are no entry, there are entity component system. So entity component system, I'll give you an example. It's like this. Entity is just an ID. So look, you just create an entity called player. Class entity is just something very basic. It only has an ID, a bit mask, a component bit mask, so you know what components you have on that entity. Then you add components to that entity, and components are just data. The direction the player has, the body, the keyboard, the whatever. It could have any sort of components. These are simple classes. They don't contain any logic. And lastly, you have the systems, hence the ECS systems. And systems can be specialized. Like, for example, I have the render system. And when you go to the render system, you inject a query which contains, hey, give me all, it contains all the entities that are renderable, and they have a sprite sheet and a position. So the render system then inside of it has a logic that it loops over each entity, like render image. This is how you can separate the concerns, like have a system for rendering, have a system for, I don't know, moving, or have a system for collision, and so on. And hence the ECS, entity component system. Entity is just an empty ID. Yeah, and you just add components to that ID. And components are simple. You don't have logic, neither entity, neither components. Because when you serialize your code, let's say you want to save game, you serialize your code, then you can just serialize the data that you have. So you're gonna have a state like, hey, this player has a body of width, this width, and then you can deserialize this and reverse to this code. Very easy. Okay, going back. So this is very different from OOP, because object-oriented programming is just a class that extends another class that extends another class, and so on. So that's the way you do it in OOP. You add more functionality by extending. Instead, here you add some data containers, which are the components, and then each system picks up entities to process them. Okay. Behaviors. Behaviors. Move a player up, down, left, right. Drop a bomb. Detonate a radio control bomb. Kick a bomb. Jump one space. Some versions. Teleport a player. Kill a player. He says environmental. This might be important. Upgrade the player future bombs. Don't affect the ones already on the floor. Dissolve a block. Spread block the explosion according to several possible rules. Data. So these are the behaviors. Data. Position of data is, these are the components. Position of each player. Here's a new component. Position component, which tie it to each component, each entity. Cell in that each player is standing on. Bombs in play. Fuse time left to the each bomb. Explosion logic for each bomb. Explosion logic. This is something that is part of a system. Explosion logic for each bomb. tiles the block shadow and coverage, tiles affected, tiles coverage. Score. This is system tied to, no, this is a component. It's a component that is processed by a system. Position of all solid blocks, position of all power-ups, position of, okay, position of all solid blocks. To me, this is like a the entity is map, and you have a component called grid, which contains the array with all the solid blocks. Convert data into components. Remember, stick to the rules. My preferred way to do this is to convert all the data into primitive data types: int, float, string, boolean, enum, list, map. For a simple game, you should never need list or map. The ones I tend to use most are enum, float, int, boolean, string. This list often contains duplicates. That's fine. We'll come back to that in a second. All data converted into primitive. Position of each player in pixel. Yeah, x, y, cell, x, cell, x. Bombs in play. Bombs in play. For each you have a x cell is y cell. Fuse time. Fuse left seconds. Okay. Explosion logic for each bomb. This is where it gets tricky. The data you store is heavily dependent on how you intend to write this behavior code on later. Let's keep it for now. This is actually the part that I'm interested. Score for each player, int, death, okay. Position of all solid blocks. Okay, we could assume that default squares are solid or empty. Let's assume solid so that anything off the edge of the playing area is inaccessible by default. Position of soft block. Is it solid? Hit points remaining. Ah, nice. You can, yeah. Position of all power-ups. Position of teleporters. Collision effect. Okay. Components after some wrangling. The heck is wrangling? Engagement in a long, complicated dispute. Okay. Now, spend some time looking at the list and think about it. Think about duplicates. All those positions in Excel are really the same thing? No. If they are not, if some of them are sort of the same but actually different or might change in the future, then you need to have two types of position component. I fully agree with this. This already happened right at the start. Then I realized that on-screen position of the sprites is similar but different from the cells in which each bomb sits. One is finer granularly than other. Yes. A very simple implementation of Bomberman could have them in the same component. Yes, but it's obvious that you want to upgrade this after only a few builds and add pixel perfect positions. Yes. Cell position, screen position, time defect, explosion, player bombs, destroyable. All these are components that are attached, can be attached to any entity. Oh, wait a second, collidable. I had a feature. Okay, collidable is a component. I was looking for the logic. It is poor, but by the time I got to the end, I changed the way I was thinking about concepts compared to the beginning. The list above is self-contradictory. It has to be redone. Firstly, the data of the explosion can be used to model most of the flame behavior so long as we treat each flame square like a depth of water that flows to either side, getting weaker by 1 point each time it moves an extra square. Secondly, I noticed that my explosion component was getting very large. Components should be small as possible. Thirdly, the enum inside my collidable were very non-homogeneous. They seem to be serving a lot of purposes at once. This is a warning sign. In ES design, heterogeneous data is what your components are for. Heterogeneous enums suggest you need to split your component. Okay. So we have two big changes to make to the second draft. On the second draft, we're going to redefine everything to do with explosions in terms of water that flows, and we're going to split two of the components into smaller pieces. Explosion, power int. Power suggests damage, but then I mean spreading. I thought for a moment. Yes, what about power-ups that explode in radius? Cool, it should be exactly the same thing. So I hastily renamed the component and that attribute cell position, screen position, timed effect, collidable. Okay. Bomb layer, something that lays bomb, not a rendering layer. Teleporter power up. Interesting, this one adds feature. Okay, but now, come on, give me the logic. I want to see the logic of this. Exercises for the reader. There's a bunch of holes in what I've written above. This post is meant to be indicative of what I'd be doing rather than a complete game design document. At this point, I think you have enough to fill in the blanks easily. No. If not, post your comments. What? Without changing anything, can you implement power-ups that disappear if not collected quickly enough? What? Sure, but with a system. What about power-ups that disappear when a player works on them? Sure, with the system. How to make power-ups that's very powerful has a risk of doing nasty to player? Okay. Consider the possibilities of your new components. I like to do this as a sanity check that my components are as flexible as they should be. But it's also inspirational to look at your system and see what emergent features it's already created. Okay. I set the vanish to take 2 more ticks than spread. Okay, this is all fine. He created some... What? What is this? What? I was expecting to show me how he did the state machine. Where's the state machine, man? Where's the logic? You can say thank you by giving your email, letting me know. Is this the whole article? I don't get it. 70 replies on designing Bomberman with an entity. Mike's gone a long way in several directions of his own. I suspect he's gone so far it's no longer an yes as I'd see it, but there's plenty of good stuff here. Thanks for the note. In a way, yes, but what I did is promote the good ideas, the work I advocate, the component actually potentially breaking. Dude, am I reading write an article here because I don't see any state machine, any system explanation. However, I believe that's one crucial thing that you left out are something I call queries. Yes, exactly. Queries are the base of systems in an ECS. Various pre-sorted lists that remove wasteful iteration and pre-calculated values based on components. You say system entity, I say system entities, component, and queries. Indeed, this is how my efforts essentially work. Oh my god, Jesus Christ. So, again, we're trying to identify in our system, we have our entities, we have components, we have some systems here, queries as well. But the question is, where do we keep our finite state machine? That was the original question. Let's see if someone asks something here. Okay, I have a question about design ideas of an entity component system. In this entity system, entities have no code. Yes, entity have no code. They're just collections of components. The components contain no code. They just hold data that is relevant in describing the entity. Correct. The system iterates over a specific group of components. Yes. By queries. By their component type. Yes, by queries. Look. You create a query from all the entities and you say, give me all renderable sprite sheet. They have sprite sheet and position. And then you can inject this into whatever systems that you have. Problem that we have right now is that nobody is saying how to use a finite state system and how to work with it, because how do you transition from one state to another given the fact that one state have, let's say, 10 ticks and has some callbacks, and the second state maybe has a different priority than the first state, and so on. I'm actually pissed on this kind of articles. So system takes the data held by the components and use code to update the state. Okay, the system take the data held by the components, yes, and use code to update the state of the entities, yes, that are composed by these components. In this regard, all the code for updating the entities is encapsulated in the systems. The systems operate on the data held by the components that make up the entity. Yes. Now, for example, suppose there are enemies in the world and an explosion goes off. Some of the enemies will die, while others will fly through the air or play fall down animations. The explosion will send a damage message to each of the entities in proximity of the explosion. So the entities will receive the message to an explosion have gone off in their an explosion has gone off in their vicinity. In this case, perhaps there is a damage component registered with the entity that listens to any damage events that the entity receives. Now my confusion is with the processing of this damage. I want to try and avoid having code present in the components. Correct. So there are perhaps two options. The damage component just records the damage event that happened. In the update loop, a damage system will iterate over damage components. The damage system code will be responsible for decrementing the health component and enabling whatever death pain animations are necessary in the animation component. All the logic for dealing with the damage event is held in the damage system. The damage component merely records the damage event it receives. Perhaps after the damaged component is serviced, it may remove itself from system updates. Aha! Until it receives another damage event and then register itself. Yes, but you cannot do this. Perhaps after the damaged component is serviced, it may remove itself from system updates. This you cannot do without a finite state machine. Because how do you know that something stopped? Unless you have the logic in the system. Hey, look, I reached tick number 10. Stop this. But then you clutter the system with a lot of crap. The damage component second solution. Damage component processes the damage event directly. That means putting logic in the component, which is not good. It decrements the health component, tells the animation component what animation to play based on the damage it received. I don't know if this type of damage handling is appropriate. Now the damage component knows that there is a health animation component. This is exactly the mistake that I did with the old system, where I registered some states, and when you look at the state knows everything about logic and render and callbacks, and it has ticks. I mean, knows when to stop, has callbacks. Okay, when you eat, at what frame of the animation you begin to actually eat, you can cancel that, and that's fine, but that doesn't work with the ECS. Let's see, perhaps there are other ways of dealing with this that I'm not aware of. How would you suggest that an explosion event be handled by the components that make up the entities being affected? Thanks for any help you can give me for posting such informative blog post. Okay, James. Hey Adam, I've remote because of any decent understanding. My problem with the general FCM structure, finite state machine structure, is that they seem to be too rigid for an ECS. I plan on making a framework tool that can be used in runtime to edit my entities and component states. They can be, so I want to be able to create something similar to states on the fly as opposed to hard coding them as components and system. FCMs aren't a great mix with ES. In fact, they're generally a bad mix for game development. What? They work with almost everything but rarely make a good fit. What does that mean, actually? If you have to use one, I'd put all in a single system processor with data in n fields in a single component. I'd put it all in a single system processor with data in n fields in a single component. Okay, so then you have the state, you keep the state in the system. If you want to soft code it, either make your system soft coded outside the remit of ES, do it whatever you want, or make the states themselves components. You can't make the states themselves components if you have custom rendering, custom logic at different frames, like Dota. Dota has an action performed at a different frame than it started. That's why you can cancel it. At that point, you've lost pretty much every single benefit of FSM, and I very strongly recommend dropping the FCM. It doesn't make sense. This opinion doesn't make sense. Okay, James, I disagree with Adam regarding FCM and ES integration, particularly this part with data in n fields in a single component. For example, when using Java, there is a collection, an enum set, which is an optimized way with a backing bit set to store the set of enums from a single type. Holy shit. And I do that. I have a component called where is it? There's a small library called where is it? Bitmask. So what they are saying is that you add a bit to the bitmask each time you have or you don't have an entity, a component on an entity. Actually, let me see here. ChatGPT, Java enum example. Enum set is a specialized set implementation for use with enum types in Java. It's a high-performance set implementation much faster than hash set, as it's internally implemented as a bit vector. This makes it a good choice when working with enums. Here's a basic example how to illustrate enum set. First, let's define an enum. Suppose we have simple enum representing days of the week. Day, Monday, Tuesday, Friday. Now we can have enum set to work with these enums. Enum all days, day class, weekend. Enum set of range. This is very important because internally is implemented as a bit vector. And I had no idea that in Java this exists in Java. A data component could have one public member enum set and store any combination of state-based enums. I agree. A single system processor could dynamically report wait a second, bit vector in Java, because I think you might be limited. For example, in JavaScript, you are limited to the architecture, so it might be 64, 63. But I somehow navigated around that in JavaScript with Begint. And big int JavaScript, I can go with large numbers, so beyond 64 bits. Okay, let's go back. Could dynamically respond to various combinations of state. You can of course use hash set. Okay. In my Java middleware component architecture entity system, I have a custom collection API implementation where all the collections are also typed data components, not requiring them to be stored in a separate data component holding a bare member variable, like how you would have to do it with standard Java collections. I take it one step further and have extensible enum set implementation, which uses extensible enums. I probably yap about extensible enums in comments above, but they come to the rescue again in defining state across module boundaries, meaning that you can mix and match different enum types still in an efficient bit set based collection without dependencies between them. What? But they come to the rescue again in defining state across module boundaries, meaning that you can mix and match different enum types still in an efficient bit set based collection without dependency between them. You can do getters, okay, containing flying, or even extensible the key, okay. A system can then use the extensible enum set to respond it via conditional code or even a FSM if desired. I already have this implemented, so I'd also suggest checking out the small section of the DoD book, which confirms that FCM are used with data-oriented design, a basis for higher-level entity system architecture. I'm not sure where Adam is pulling FCM is bad for his entity system game development in general. In the simplest way of organizing data components with discrete member variables as suggested by Adam above, it's a bad thing given how rigid that should be. In the simplest way of organizing data components with discrete members variables. However, just add an enum set and whatever. Yes, okay. Okay, so we have to read this, but then, yep, there are much better ways on a language by language basis. Java went from terrible support for enums to best possible. FCM are a bad code smell, in my opinion. Usually, there's a better way modeling whatever they represent. Adam, FCM are a bad smell. I think leaving out the imho in your original response perhaps put me a bit more on the edge. And I agree that defaulting to FCM for general use cases is not the best. It certainly is not easier to build a good one versus bespoke system creation for adding logic incrementally. However, there is nothing inherent about FCM that clashes with ES architecture. When data is properly formatted for the FCM implementation, using the ECA itself composition of data components to define type of state to drive the FCM is inefficient. What? Using the SA itself composition of data components to define type of state to drive a FCM is inefficient, but that is because that is an inefficient way to define types for any SA use case. FCM certainly has more weight in middleware that provides a GUI-based editor and is specific to, say, AI or input control, any state used in the AI system. It's reasonable in the domain of building a generalized framework. As you mentioned, creating specific processor systems to explicitly service particular logic is generally the right approach, especially when incrementally modifying a project. Yes, but where do you keep the state per entity? That's my problem. Okay, so this article again simplifies everything and doesn't really provide a good solution. Let's continue with the original thread. ECS is awesome, but it's not something you can use for everything. Entities are about data. A state machine is about code structure, how you execute different things based on context. The two concepts don't seem compatible. This page is from beta release of data-oriented design book. Oh, and here we have an introductory, I think, a discussion about finite state machines. Finite state machines are a solid solution to many game logic problems. They are the building block of most medium-level AI code and provide testable frameworks for user interfaces. Notoriously convoluted finite state machines rule the world of memory card operations and network lobbies, while simple ones hold domain over point-and-click adventure puzzle logic. Finite state machines are highly data-driven in that they react to an alphabet of signals and change state based on both the signal received and their current state. Yes. So we have a book. Okay. Finite state. In the contents. But there's no chapter on this. What the heck? Tables as states. Implementing transitions. Is this like... Okay, tables. If we wish to implement a finite state machine without objects to contain them and without state variables to induct their flow, we can call on the runtime dynamic polymorphism inherent in the data-oriented approach to provide these characteristics based only on the existence of rows in a table. Bam, bam, bam. At the fundamental level, a finite state machine requires a reaction to an alphabet. This to me is very important. If we replace the alphabet handling code with condition tables, then we can produce output tables of transitions to commit. If each state is represented by a condition table and any entity in that state represented by a row in a state table, then we can run each state in turn, collecting any transition buffers, then committing these changes after everything has finished a single update step. Okay. What if you implement each state of ECS component so you will have one system for each state. I don't know, that seems very messed up in my opinion. State machine has int and num representing from state to state has so state machine component from state to state has a time I'm working on an implementation of this in similar concept that Ash framework and ECS framework from the action script. I didn't figure out the implementation detail, but is this line state machine component state actual state a now mean string next state if different than state indicate pending transition state component map a dictionary of state ID and arrays. Yeah, you have to have all the states registered in advance, that's for sure. State exit run first. If next state is different state, remove all components from state from the entity. You know what? Anybody has thoughts on value task? All the sync await stuff is in C#, is basically syntax for state machine. Property is cancelled, is completely faulted. This is a task. This is not a not really a state machine. It's more like a task system, and I have a task system. Where is it? Task manager. Right, I have a task manager, which is a basic thing. State manager, and my state manager is kind of you know what I will do? I will just I think at the end of the day I need to implement the state anyhow, the state library anyhow, and then I'll see how to merge it into this burst compiler C# jobs entity component system. Reactive system to provide an on enter and on exit. I have to look into this because yes, a system state needs these kind of on enter and on exit. Look, enter and exit. You see, you need these methods. So I need to look at this presentation. So what was the link here? Technology use assets. ECS samples, assets, use cases. AI. State machine. State machine. State machine guard AI. For reference, the latest entities package documentation is here. This sample demonstrates how a state machine for AI agents can be implemented using ECS. The principles are illustrated using a prototypical stealth game. You move your character through a 2D world using WASD keys and try to avoid being seen by a guard. The guard's AI is essentially a state machine. This sample consists of scene state machine AI unity, which includes a player object, a game guard object, 2 waypoints. The enemy's guard authoring component contains a list of waypoints. Both the player and guard have a convert to entity component attached with which converts their data into the appropriate component data needed for ECS when entering play mode. Okay. Problem statement. We need a guard AI for a simple stealth game. The guard patrols between waypoints, waits at the waypoint once reached, and chases the player if seen. I need the same for my game. If the player gets too far away from the guard stops chasing the player and returns to patrolling. For this game, we expect 1 player and 10 guards on a single map. Every guard will have between 1 and 8 waypoints. The waypoints will be hand-authored by the editor. Player and guard parameters such as moving speed, idle time must be authored in the editor. Our solution. From the requirement, we identified that we had 3 distinct states. three distinct states of guard: patrolling, chasing, idling. Patrolling, this guard needs to know where it is going. Okay, for this we need a list of all the waypoints. Waypoint position. When they reach their destination, the guard chooses idle. Check reached waypoint system. Oh, okay, so it has a system for check reached waypoint. Holy crap. The update idle timer system is where the guard will transition from idling to patrolling. Wow. So a system for each of these stuff. Idling, the guard needs to know how long it has been idle, the idle timer, and how long it's supposed to be idle, cooldown time. Every frame we need to update the timer based on the time that has passed. Update idle timer system. Then when it's finished, the guard returns to patrolling, selecting the next waypoint. Next waypoint index. The check reached waypoint system is where the guard will transition from patrolling to idling, and the look for player system is where guard can transition from chasing to idle. So they use a tag for is chasing tag, which is actually a component as well, I think. Persistent data, cooldown time, vision cone, movement, dynamic. Okay, chase, target position, state. Give me a second here. Move toward targets. Designing the statement. First, we looked at a few facts about the problem. Guards spend most of their time in patrol state and idle state. The frequency of the state changes is authoring data dependent, but typically rather low. It will typically be, so depending on how you design the map, it will typically be multiple seconds in between state changes for each guard. Due to these factors, we elected to use changing archetypes and specific entity queries to store and process the guard entity data. Because our system only operates on entities which have the required data types, ECS handles the sorting of these entities such that the entities in such state are stored together in chunks. This makes processing of all entities in a particular state more cache efficient. Example, the update idle timer system queries only for entities that have an idle timer. We don't have to process and skip entities that are chasing or patrolling. Low state change frequency keeps the amortized cost of changing archetypes, which requires copying component data from chunk to chunk. Other solutions that we considered. Say we created a shared component with an enum to represent the three states. Yes, okay. When we change the state of the guard by updating the shared component value, the guard entity moves to a different chunk. I see right now what they're saying here. Using a shared component in this case does not provide any advantages over the pre-archetype solution. Both require moving chunks. The entities for each would need to use a shared component filter so that all the states were running for all the guards at the time. Since querying with filtering is more expensive than separating chunks by archetype, querying with filtering is more expensive than separating chunks by archetypes. This would result in a performance regression. We could also keep the enum val inside of a normal iComponent data and never change the archetype. All guards would have the necessary data for every state, thus all guards would be in the same chunk and no moving operations need to be performed. Each system would check the state for every entity and skip those that are not in states that system processes. Performing this conditional logic frame when the state changes at most once every few seconds is almost unnecessary. Yeah, agree. Okay, and how do I see the code here? Give me I. So you have a transition from patrolling. Used to remove the component needed to transition out of idling state. So transition from idle means that it removed the idle. Wait, what? Transition from idle. Transition from patrolling. It looks like it's just a removal of components. Okay. Where is chasing tag? I want to see this symbol somewhere. I don't see it. Transition to idle. Add component. Okay. Oh my god. Okay. This is good to know. So it appears that in this Unity implementation, they do these add and remove component stuff. They even have an is in transition tag. Okay. State machine. Wait, what's this? On update. Create timer delta for each entity. Transition to idle. So they have a system for everything. Okay. I'll pause this. When I come back, I will just focus on the state machine as a separate repository. So basically, I will have a new repository called glhf fcm from finished state machine. I'm gonna implement the finished state machine there, and then I'll start I'll just try to understand how to put that into existing code, existing ECS code, because it's like nobody explained it. Nobody. They have this utility function. This looks like not function, like container for these methods. This is like having a state machine, honestly. So yeah, and I'll see how to do this. Maybe I have a state machine system, because I need to have some sort of system. And basically as a method to signal that player is no longer walking. And also this removing of a component, this works, but it feels like there's a lot of memory going on if you do this. Is walking, not walking, is, you know, it's like I like the tagging part. The tagging, the fact that you know you can add whatever tag you want. The fact that you know that the player stopped or yeah, we'll see. So see you on the next one.